Good day to my supervisor, markers, and my fellow peers. Today I will be presenting under the topic of polymerization of ketosane starch-based nanocellulose composite film and the optimization for protective layers formation. As most of y'all are not familiarized with these terms, let me break it down into more simpler vocabulary. For this, I have prepared three questions in the introduction. Firstly, what are composite films and its applications? So, composite films and coatings refer to systems where multiple biopolymers have been combined to achieve beneficial properties such as improving shell life and quality of different food products. This includes vegetables, fruits, dairy products, meat products, and so on. Most commonly used biopolymers are polysaccharides, proteins, and lipids for developing such systems. The main function of food coatings or films are to preserve the quality of the food. Such functions include prevention from chemical, physical, and biological damage to the food. Chemical damage is caused by exposure to gas, light, or moisture. Physical damage includes the damage to the film caused by vibrations or shocks, whereas the biological damage refers to pathogenic activity or aging of the food. Moving on to the next question, what are ketosane and starch? So ketosane and starch both are polysaccharides. Ketosane is a polysaccharide derived from chitin, which is the second most abundant biopolymer after cellulose. Chitin is found in the exoskeleton of shellfish such as crabs, lobsters, and shrimp, whereas starch is produced by most green plants for energy storage. Ketosane and starch-based materials are widely used in many applications because of its biological and physical properties of biodegradability, biocompatibility, relative abundance, non-toxicity, resistance to degradation, and easy film forming ability. However, the differences of these two biopolymers are ketosane has a very good antimicrobial ability and starch can be easily modified. Therefore, in my research project, I will be making a composite film blending starch and ketosane together to have superior properties of both these biopolymers. Lastly, what is nanocellulose? Simply, nanocellulose is a light solid substance obtained from plant matter which is consisted of nano-sized cellulose fibers. This can be used in the composite film to optimize the barrier properties of the films. In my research project, I will be extracting nanocellulose from banana pulp. Further studies of this will be illustrated in the FYRP 2. So the aim of the research project is to conduct experimental research to develop starch ketosane based composite film and to conduct tests to determine the ratios and their mechanical strengths to propose the best composite film. And this gives rise to a series of research questions as which ratios of the biopolymers will give the most effective composite film and what additives can be used to optimize the properties of the composite film. Before moving on to the literature review, it would be crucial to talk about the significance of the research project. So sustainability is an important aspect in the engineering world. However, food packaging industries are facing issues due to the application of petroleum-based polymers which are not recyclable or biodegradable, which leads to severe ecological problems to the environment. Therefore, these petroleum-based polymers are being replaced by biopolymers which are ecological, eco-friendly. So now moving on to the literature review, firstly it is important to discuss the pre-treatment of chitin. Chitin needs to undergo a chemical extraction process before it is used in applications where it undergoes two processes known as chemical deproteination and chemical demineralization. So briefly explaining, in chemical demineralization, minerals such as calcium carbonate, phosphorus, and other toxic minerals are removed. This is accomplished by acid treatment using sulfuric acid, hydrochloric acid, nitric acid, and formic acid. However, according to the literature, the superior reagent out of these is hydrochloric acid. In this process, calcium carbonate is decomposed into calcium chloride with the discharge of carbon dioxide. Chemical deproteination steps includes the disruption of the chemical bonds between proteins and chitin, which involves the use of chemicals to depolymerize the biopolymer. Removal of the protein is important as the protein content is the chief culprit to bringing allergy to the human population. This is accomplished by alkali treatment using sodium hydroxide, which leads to deproteination but also results in the hydrolysis of biopolymer, dropping its molecular weight and partial deacetylation of chitin. So deacetylation is the removal of acetyl groups in chitin and substitution of reactive amino groups. According to research work in chemical method of deacetylation, either alkalis or acids are employed to deacetylate chitin. Since glycosidic bonds in chitin are quite vulnerable to acid, alkalis are proposed to be a better choice. Another important aspect is to discuss the existing issues of biopolymer films and the ways of optimization. Currently, food packaging industries are facing issues where the durability of the existing films do not last long enough, which leads in microbial alternations in food. Another similar issue is caused due to films that lack strength, which cannot withstand high temperatures, water permeability, gas permeability, and even physical damage. So in order to overcome this problem, plasticizer are added to provide the necessary workability to biopolymers. Plasticizers are an important class of low molecular weight non-volatile compounds that are widely used in polymer industries as additives. These substances reduce the tension of deformation, density, viscosity, and electrostatic charge of a polymer at the same time as increasing the polymer chain flexibility and resistance to fracture of the film. Hydrophilic compounds such as polyols, most commonly glycerol and sorbitol, are used in starch and chitosan films to improve their mechanical and barrier properties. The recrystallization of starch restrains starch from coming into real practical use because it easily becomes rigid and brittle during long-term storage and therefore loses its value in use. Overcoming the brittleness of starch while achieving full biodegradability in blends can be accomplished with the addition of biodegradable plasticizers such as glycerol. The methodology of my research project is consisted of three major parts. Initially, the preparation of chitosan starch film would be the first challenge for my experimental research. According to the research so far, I will be making a chitosan solution of 2% concentration. This is prepared by dispersing 10 grams of chitosan in 500 milliliters of lactic acid solution of 1%. After dissolving the chitosan completely, the solution can be filtered by using the method cheesecloth by vacuum aspiration. When making the starch solution, I will be using regular starch, which is also known as 25% amylose cornstarch. Using this, I will be preparing starch solutions with 4 different concentrations as 1%, 2%, 3%, and 4%. This is done to test the effect of starch to chitosan ratios on the mechanical properties of the films. The starch is dispersed in the distilled water, which is heated and stirred until the starch is gelatinized, and this temperature could range from 60 degrees Celsius to 95 degrees Celsius. After gelatinization, the solution can be cooled to 25 degrees Celsius. After making separate solutions of chitosan and starch, a series of chitosan starch composite films can be prepared by mixing 100 milliliters of 2% chitosan solution with 4 different concentrations of starch solutions. To this solution, glycerin needs to be added as 25% of the total solid weight in solution. The purpose in adding glycerol was discussed earlier, therefore I will not be taking the time to discuss this again. The mixture will be casted onto a Teflon coated glass plate. After drying the films at room temperature for at least 72 hours, they can be peeled from the plates. Then should be conditioned at 50% relative humidity at room temperature for 48 hours prior to testing. The second part is where the evaluation of the interactions between starch and chitosan will be examined using FTIR spectroscopy, and the crystalline structure of the polymer will be further examined using X-ray diffractions. This will give a better idea of the compatibility of the starch and chitosan as a composite film and use the additives to make the film more effective. In the third part, the testing of the mechanical properties of the composite film will be studied using equipment such as Instron Universal Machine for the testing of tensile strengths and elongation values of the film. The use of gravimetrical modification of ASTM method can be used to find the water vapor transmission rate. So my future works will be done in the winter break and semester 2, where I will be conducting research on the infusion of nanocellulose to the composite film and the preparation of the composite film, and conducting experimental tests on the properties of the film. Finally, I would end this presentation by expressing my sincerest gratitude to my supervisor, Dr. Bazlul, for his support and guidance. Thank you. Have a nice day.